Good day, viewers all over the world. My name is Honorable Maji Solomon. Right now, I'm going to treat Boyle's Law. Boyle's Law in the field of chemistry. Boyle's Law. Chemistry. Topic. Boyle's Law. Boyle's Law in the field of chemistry. Teachers are expected to treat this topic. Boyle's Law. Boyle's Law states that the pressure of a given mass of gas is inversely proportional to its volume at constant temperature. Boyle's law states that the pressure of a given mass of gas is inversely proportional to its volume at constant temperature. All right. Boyle's law, Boyle's law states that states that Boyle's law states that the pressure of a given mass of gas is inversely proportional to its volume at constant temperature. P1 V1 P1 equals to P2 V2. Temperature remains constant. P1 V1 equals to P2 V2. Temperature remains constant. Where where P1 V1 are the initial pressure and volume of the gas. P2 V2 are the final pressure and volume of the gas. Boyle's law states that the pressure of a given mass of gas is inversely proportional to its volume at constant temperature. P1 V1 equals to P2 V2. Temperature remains constant, where P1 V1 are the initial pressure and volume of the gas. P2 V2 are the final pressure and volume of the gas. I'm going to set a question on this. Example 1. Example 1. The volume of a given mass of gas is 380 centimeter cube at a pressure of 770 millimeter of mercury. 770 millimeter of mercury. The volume of a given mass of gas is 380 centimeter cube at a pressure of 770 millimeter of mercury. Calculate its volume at 760 millimeter of mercury. Temperature remains constant. What do? What are you going to do? Solution. P1 V1 equals to P2 V2. Solution. P1 V1 equals to P2 V2. Temperature remains constant. Okay. P1. Our P1 is what? Our P1 is 770 millimeter of mercury. Our P1 means initial pressure. Our P1 is 770 millimeter of mercury. Okay? Our P1 is 770 millimeter of mercury. Okay? Our V1 means initial volume. V1 means initial volume. Our V1 is 380 centimeter cube. 380 centimeter cube. 380 centimeter cube. 380 centimeter cube. Okay? 380 centimeter cube. Okay? Our P2. Our P2 is what? Our P2. Look at our P2 means final pressure. It is called pressure, not pressure. Not pressure. It is not called pressure. It is called pressure. Our final pressure is 760 760 millimeter of mercury. 760 millimeter of mercury. Okay? Our V2 is not given. Our V2 is not given. Look at the question mark. Our V2 means final volume. Final volume is not given. The final volume is not given. And this is the right time for me to find the final volume. Final volume is not given. Final volume is not given. This is the right time for me to find the final volume. Final volume. Final volume. I am going into calculation so as to find out the final volume. Final volume. I'm looking for the final volume because the final volume is not given. The final volume is not given. This is the right time for me to find out the final volume. This is the right time for me to find out the final volume. This is the right time for me to find out the final volume. Final volume is not given. Final volume is not given. Final volume is not given. This is the right time for me to find out the final volume. Final volume is missing. This is the right time for me to find out the final volume. Final volume. Okay. V2. I'm looking for the V2, which is our final volume. V2 is not given. V2 is not given. Now I'm going to make this V2 as a subject of the formula. V2 equals to P1 V1 V2 equals to P1 V1 all over P2. I'm looking for V2. V2 is not given, as you can see here. V2 is not given. So I'm looking for V2. I'm going to use this formula so as to get our V2. I'm going to make use of this formula so as to get our V2. Okay. V2 equals to P1 means initial pressure. And our initial pressure is our initial pressure is 770 millimeter of mercury. 770 millimeter of mercury. Okay? What do? P1 here means 770 millimeter of mercury. Okay? Times P1, V1 means P1 times V1. Okay? Now, our P1 is given. Our initial pressure is given to be 770 millimeter of mercury. 770 millimeter of mercury. Alright? Okay. What is the next line of action? Multiply this by V1 times V1. Our V1 means initial volume. Our V1 is 380 centimeter cube. 380 centimeter cube. 380 centimeter cube. Okay? All over P2. All over P2. Our P2 is what? Our P2 is 760 millimeter of mercury. Okay? 760 millimeter of mercury. 760 millimeter of mercury. Okay? What do? V2. I'm still looking for my V2. V2 was to, as you can see, millimeter of mercury. I'm not going to make use of millimeter of mercury at the end of it all. If I'm able to get my V2, I'm not going to make use of millimeter of mercury at the end of it all. I'm going to make use of centimeter cube at the end of it all, because I'm looking for the final volume. And volume must carry centimeter cube. Okay? So I'm looking for V2. I'm not looking for pressure. I'm looking for volume. Final volume. I'm looking for final volume. Okay, now, since I'm not going to make use of millimeter of mercury, I have to remove millimeter of mercury. I have to remove this one also. Now, I'm left with 770 times 380 centimeter cube. Okay? If you multiply 770 by this number, 770 times 380, the answer is 292,000. If you multiply this and this, multiply 770 by 380. 770 times 380. The answer is 292,600. 292,600. 292,600. All over our P2. all over our P2. Our P2 is 760. You write it underneath. 760. Okay? 292,600 divided by 760. The answer is 385 centimeter cube. If you divide this number by this, the answer is 385 centimeter cube. I have succeeded in getting my V2, my final volume. I have succeeded in getting my final volume. My final volume is 385 centimeter cube. Thank you so much.